All right, welcome. Let's be honest. Have you ever found yourself just staring at a mess of wires and, well, just guessing? Today, we're going to change all that. We're going to pull back the curtain on one of the most powerful tools any DIYer can own, and we're going to turn all that electrical guesswork into real, solid knowledge.
I think almost everyone has a story like this. As a kid, you're curious, right? You see a power socket, you find something metal, and then you hear that voice from across the room yelling at you. It's kind of funny to look back on, but it really gets at the core problem. Electricity is this totally invisible, super powerful force, and trying to deal with it can feel like a complete mystery.
And that really is the big question, isn't it? If you can't see it, or smell it, or even touch it safely, how in the world do you know what it's doing? How do you work with it without just crossing your fingers? Well, you need a way to make that invisible stuff visible.
Which brings us right to our first and honestly our most important rule. From this point on, we're moving from the world of guessing into the world of knowing. Because when it comes to electricity, guessing is, well, it's not a strategy, it's a gamble.
It's that mystery, that invisibility, that's what makes electricity so potentially dangerous. So to work with it safely, you need two things. The right tool, for sure, but maybe even more important, you need the right mental model. So let's build that model right now.
And here is the secret weapon for understanding all this. It's the single best analogy I've ever heard for electricity, the humble garden hose. Seriously, if you can understand how water moves through a hose, you can totally grasp the basics of an electrical circuit. Think of this as your Rosetta Stone. Okay, first up, volts. Just think of volts as the water pressure. It's the amount of push behind the electricity. When you turn the spigot all the way up, you have high pressure. That's high voltage. Barely turn it on, and you've got low pressure, low voltage. It's just the force waiting to move. Next, you've got amps. So if volts are the pressure, amps are the actual flow. It's the volume of water that's actually coming out the end of the hose. A big gush of water is high amps, a tiny little trickle is low amps. It's the amount of electricity that's actually moving.
All right, now what about ohms? This is resistance. And the analogy here is perfect. Imagine you step on the garden hose. You put a big kink in it. Now the pressure from the spigot, the volts, is still the same, but you've restricted the flow, right? That kink is resistance. It's anything that makes it harder for the current to flow.
And last but not least, continuity. This one's easy. It's just a test to see if the path is clear and unbroken. With our hose, it's like checking to make sure there are no leaks or holes between the spigot and the nozzle. For a wire, the test sends a tiny signal through it. If the signal makes it out the other side, you hear a beep. That beep means the path is good.
Okay, so now we have the concepts down. Pressure, flow, resistance. Let's meet the hero of the day. This is the multimeter. This is the tool that takes all those invisible ideas and turns them into actual numbers that you can see on a screen.
And getting started is way simpler than it looks. Really, you only need to know three things. First, the black probe, that always goes into the port labeled COM. That stands for common. Second, the red probe goes into the port for whatever you're measuring, usually labeled V for volts or ohms for ohms. And third, you just turn that big dial to the symbol that matches what you want to test. That's it. You're ready to go.
Look, theory's great and all, but let's make this real. Let's put this knowledge to work. We're going to walk through a couple of super common tests, especially if you're working on something like a van or a boat, any kind of low-voltage system.
Here it is, the question that every single van owner asks themselves probably every day. You've been running your lights, your fan, the fridge, but how much juice do you really have left? Guessing can mean the difference between a cold drink and a dead battery in the middle of nowhere, so let's measure it.
So, the process is super straightforward. First, you're going to turn that dial to DC volts. That's the V with a straight line, not the squiggly one. Then you just touch the red probe to the positive terminal of the battery, the plus sign, and the black probe to the negative terminal. The meter will instantly give you a reading. And boom, there's your answer. A reading around 12.7 volts means you've got a healthy, fully charged battery. If that number drops down to something like 12.0, you're already at about 50%. See that? No more guessing. You have a precise number you can actually use. Okay, let's tackle another super common problem. Say a light in your van suddenly stops working. You check the bulb, it's fine. You check the fuse, it's also fine. So, could the wire be broken somewhere inside that plastic coating? Instead of tearing your whole van apart, we can just test for continuity. Now, listen up because this is the most important part. Before you test for continuity, you absolutely must disconnect that wire from any power source. Unplug it from the battery, whatever it takes. Safety first, always. Okay, once it's dead, set the dial to the continuity symbol. It usually looks like little sound waves. Touch one probe to one end of the wire and the other probe to the other end. If you hear that nice loud beep, the wire is good. The path is clear. If you hear silence, you found your broken wire. Simple as that.
All right, we've seen how incredibly useful this tool can be, but all that power comes with some serious responsibility. So we're going to end this with the most important section of all, how to do all of this safely so you can test with real confidence.
Please pay very close attention to this slide. As a beginner, you should only be working with low-voltage DC power. We're talking about your car battery, your van's solar system. That stuff is relatively safe to learn on. What is not safe for you is AC power, the kind that comes out of a wall socket. That high-voltage stuff is a completely different animal, and it can be lethal. Seriously, leave that to the pros.
So let's just run through the safety checklist one last time. First, as a beginner, stick to DC power your batteries. That's it. Second, never, ever stick your multimeter probes into a wall socket. Third, always double-check that your dial setting and where you plugged in the red probe match the test you're about to do. Fourth, don't do this stuff in the rain or with wet hands. And finally, the biggest rule of all, if you are even a tiny bit unsure about something, just stop. Ask a professional. There is zero shame in asking for help when your safety is on the line.
So there you have it. You've got the mental model with the garden hose, you've met the tool, and now you know the rules. It's really time to stop guessing and start measuring, because the whole point is to solve problems, to learn a new skill, and most importantly, to do it safely. So ditch the knife, grab the meter, and stay alive.